Welcome back. Hope you enjoyed those challenges, and we're on to the third section of level 4. We're going to try to count some fish in our tank. What if we wanted to know exactly how many fish we have inside of our tank at any given time? Let's take a look. So we've got our aquarium object, and we've just used some icons here for shorthand, but just know that those represent the objects that we've added or that were in there earlier. You'll notice that we put bubbles up near the front with the other fish just to have a little bit better organization for this task. So let's count our fish. Let's see how many fish we've got going on here. The first one is the Nemo property, and if we look at its type, we see that Nemo is definitely a fish. We'll follow that with Dory. Dory is also a fish. Bubbles is a fish. But Peach is an echinoderm. We call it a starfish. It's not really a fish. Then we move on to the Coral Castle, and that's an environment. We'll add critter as a function, it's definitely not a fish. And take out, same thing, it's definitely not a fish. So, 3 fish total, right? And how we did that sort of feels like a loop. So intuitively we sort of think maybe if we loop over the properties of our object, we could find out how many fish are in there just by checking the type. There's one caveat here though, and that's that the aquarium does not have a length. That's completely undefined. It's not like an array where we can just count the cells using the length property. Because generic objects don't really have a native length, like arrays or strings, we would not be able to use that length inside of a loop parameter. We need a different way. Welcome to enumeration using the for-in loop. It's a new kind of loop we're going to show you right now. The for-in loop will let us access each of the enumerable properties in turn. You might ask what enumerable means. For right now, you should just know that it means every object or property that we have added to this object ourselves. We'll go into exactly what enumerable means in a later course. So here we have our very special for-in loop. You can see the for keyword, which looks just like the for loop keyword. But inside the parameters of this loop, you can see on the left-hand side the word key. And in between the two words is in, and on the right-hand side is aquarium. Now key here represents every single property that is present inside of aquarium. And the in keyword will look in the object on the right-hand side for every possible key on the left-hand side. You can think of it like accessing each index of an array. Now, if we were to log out each of these keys, which you know are just property names, we would get Nemo, Dory, Bubbles, Peach, Coral Castle, add critter, and lastly, take out. Something to note here is that our word key is not any special keyword or anything. We could use whatever name we want before the in keyword to refer to each property inside the object, such as, say, item, or even the letter P for property, or any real intuitive word that you like. Think of it like a parameter that points only to the string names of the properties. The cool thing is that it's a name you get to create. For now, though, we're going to go ahead and stick with key since it's an often used word to describe the name of a property within an object. Now that we've got our enumeration set up, we need a way to determine which properties in the aquarium are actually fish. First thing we'll do is we'll set up a variable called numFish. That's going to be our counter. Then we set up a conditional where we ask the aquarium if the current key that we're on, which you know is just a property name string, has a type that is fish. Something to note here is that once we've accessed the object that the key refers to, we can just check out its type property to see if it matches the string fish. And if that's true, we'll go ahead and just increment our numFish variable. What happens though when we get to the add critter function, which is way down there at the end of the object, and we try to access it and then see what its type property holds? Well, that's going to be undefined, so that's still okay because undefined does not equal fish, so we will never increment our numFish variable on a function. So let's check out how our loop actually progresses. The first thing that happens is that key becomes Nemo. That's our very first current property. And so our conditional looks up aquarium Nemo and asks, does it have a dot type? Does it have a type property? Yes, it does. Let's check it out. What is it? It's fish. So does type equal fish? Yes, it does. That's true. And our numFish variable is incremented to 1. The same thing happens for Dory. It does have a type property, and that type is fish, so we get numFish incremented to 2. And then when we do Bubbles, the same procedure happens, and we get numFish incremented to 3. But then we get to Peach. And it does have a type property, but its type is not fish, it's echinoderm. So type is not equal to fish, and we do not increment the numFish variable. Same thing occurs with the coral castle because its type is environment. Lastly, we get to add critter, and it doesn't even have a type variable, so it will be undefined, and that will stay false when we try to check whether the type is the fish, and we will not increment numFish for either add critter or takeout. And if we try to log out our numFish variable, we can see that we have 3 fish inside of our aquarium. Now we've built all of this functionality outside of the object. We really want to put that inside the aquarium so that we can call an aquarium fish counter. So let's scoot our stuff over here, and we'll go ahead and establish a new property inside of our aquarium called aquarium.countFish. And we'll assign a function expression to that particular property. Inside it, all of our code that we built. Now, something special needs to happen inside of our code though, because every place that we had aquarium, can you think of what we're going to place here? We're going to put the this keyword. That's right, because it needs to refer to the owner object of the function that's being called. Additionally, since we're building a function, we now need to return something from that function, so we'll go ahead and return our numFish variable. Magically, our countFish function appears inside of our aquarium object. And when we call aquarium.countFish, we get 3. Awesome. Let's take Dory out. We'll establish a pour Dory variable, and we'll call aquarium.takeout on Dory. Dory pops right out. We'll scoot our objects closer here. And the delete that happens inside of takeout will return us a true. And now Dory is held inside of pour Dory. If we were to now call aquarium.countFish, we appropriately get 2 because now there are only 2 fish inside the aquarium object. And that is the end of the ocean of objects. Now we've got a bunch more challenges here for you to really test the work that you have done with these objects. Hope you've had a great time, and we'll see you back in the next level. And that's what gets First, we need to delete. What a colossal fail.